Okay, welcome students. This is Mr. Gee, and we are doing a video on our next topic, which is solving equations with rational coefficients. A rational number is a number that can be written as a fraction. You can see here we have an integer divided by an integer. Here we have an integer is like a positive and negative number. So some of these sometimes it can be like a -1/6 or a -2/8. But anyway, we're just taking like a whole number, positive, negative type whole number, and we're dividing them into each other. We commonly talk about these as fractions, but it's for the core it's called a rational coefficient. So when we do these type of problems, the first thing that we want to do is put a 1 where you need it. If you look right here, I have a denominator of 6, here I have an 8, but 4 and 5 don't have a denominator, so I have to put a 1 there. So you see where I put that 1? So put a 1 where you need it. Over here, if I was doing problem number 2, I would have to put 1 over 1 here, and I'd have to have 2 over 1. Okay, so hopefully you get that okay. All right, now the next thing that you have to do, and this is the most important step. Now one thing that we talked about is multiplication by 1. So if I have 8 over 8, remember that's a 1. I have 6 over 6, that's a 1. And I have 48 over 48, that is also 1. So what we have to do with these numbers, we have to find a common denominator. You can see here I have a 6, I have a 1, and here I have an 8, and I have another 1. So the idea is this: if we take all these denominators and we multiply them together, 6 times 1 times 8 equals 48. So I have to change all my denominators, all these right here, to 48. So if you take a look at a 6, we know 6 times 8 is 48, so the 6 is missing an 8. So I'm going to multiply this 1 over 6 by 8 over 8. And what I end up getting is like 8 over 48, but it's still the same as 1/6. Now if you look at the 4 has a 1 as a denominator, so to get a 48 on the bottom, I have to go 48 times 1 will give me 48, so I have to do it to the top and the bottom, which again, that is 1, and we know that 1 times anything is at anything. So 1 times 4 is still 4, but I'm going to use 1 as 48 over 48. Okay, now the next one here, you can see that I have an 8 here, so I want to times it by 6 times 8 on the bottom will give me the 48 that I need, and so I have to do it to the top and the bottom, so I'm multiplying by 1. And then here I have a 1 on the bottom with the 5, so 48 times 1 will give me the 48 that I need on the bottom, and I also have to do it to the top. So the idea is that we take a look at where we need a 1, we put it, and then we're going to change all our denominators using some form of 1 to make them all the same denominator. Now this is why we do that. Let me go to this next layer. So this is what happens when all the denominators are all the same. So here I have 8 over 48. I have 48 times 4 is 192 over 48. 2 times 6 is 12x over 48. And 5 times 48 is 240 over 48. So when the denominators are all the same on every term, you can delete them. You can drop them all the way out. And the only time that you can do it is if you have an equation. If you don't have an equation, you cannot do that. Okay? Now let's see what happens when we drop them. So take a look at this really, really closely, and let me zoom in. Look at that. If I drop the 48, I get an 8x. If I drop the 48, I get 192. If I drop the 48, I get 12x. If I drop the 48, I get 240. So do you see, this is the type of equation that we learned how to do last week. So all the steps you already know to solve these type of equations. The number on the left we take to 0. We do the same operation to both sides. The variable on the right we take to 0. Do the same operation to both sides. 8 minus 4 is a -4x. 240 minus 192 is 48. Now the last step we all know to this is we divide by the coefficient in front of the x to both sides. We divide the coefficient by itself, and look what we get. -4x divided by -4. I do it to this side, and I end up getting x equals a negative 12. And that is the answer. Okay, in this next problem we're doing number 2. Again, you can see that we have a rational coefficient. Remember, a coefficient is a number in front of a variable, and we call these rational numbers because we have a number divided by a second number. And this problem is basically kind of the same, but one thing that's a little bit different here is we have 5 divided by 5, which is kind of weird because we end up having a 1 here. Now you could go ahead and change this to 1, but to go ahead to make this more similar to what we've already done in this other problem, we're going to leave this 5 over 5. Now going back to the steps that we have, step number 1 is we have to put a 1 where you need it. Now how you know that you need a 1 here is there's no denominator. So if you have any terms that don't have a denominator, you have to put a 1 there. Now if we take a look at the common denominator that we want, it doesn't have to be the lowest, like you heard a lot about the lowest common denominator in 2nd or in 7th grade. Here it'd be nice if we use the lowest one, but this will be okay. We're going to take 3 times 5 times 1 we know equals 15. Now what we want to do is take a look at the numbers that are missing to get the denominator to go to 15. So if I like 4/3 x, let me go ahead and do this in blue. Do you see the 3 times 5? This 3 is missing the 5 to get 15. That means I will multiply 5 on the bottom, and remember I have to use a form of 1, so I'm going to do the 5 on top. Now when you multiply in fractions, it's numerator times numerator, denominator times denominator. Okay, let's take a look at the 1. We know that 1 times 3 times 5 gives me 15, so that 1 is missing a 15 on the top and a 15 on the bottom. I know that 1 times 15 is 15 to get the denominator to 15, and to make sure that I'm multiplying by 1, I have to do it on the top as well. I'm going to go ahead and change this to blue because I want to show the changes that I make in blue. So do you see where I'm multiplying by 1, multiplying by 1? And again, 1 doesn't change anything, right? And then this will give me the 1x. And then you can see I have the next one, I have a 5. And the 5, if you look at the 5 is missing the 3. So I will multiply 3 to the bottom and 3 to the top. There's my 15. 3 times 5 is 15. 3 times 5 is 15. It's still the same as 1, right? So it's not going to change anything. Okay. Now let's go ahead and continue with this. Let me change back to the red.
The
now
time is
here,
9 o'clock.
Oh, sorry about that. 9 o'clock, people. It's time for bedtime. So now here I have a 1 again, so I will do 15 over 15. Now this may seem like it takes a long time to do, but once you do this a few times, like on the worksheets that we're doing today, it goes relatively fast because the math is not really complicated. It's straightforward. You're just using this idea of 1 again, just like we did. We're using it in a different way than we did before, but it still works. Okay, so do you see that? Now let's do our multiplication. 5 times 4 is 20x. 5 times 3 is 15. See how that works? I'm going to move this up just a little bit so I don't run out of room. There we go. 5 times 1 is 15. So that's 15 over 15, which is the same as 1. This becomes 15x over 15, which is the same as 5 over 5, correct? And for the last one, here I have, I don't think this is right, is it? Oh yeah, it is. I should have 30 over 15. Because I had to go 15 over 15 to the top and bottom. Now do you see where I have the same denominator everywhere? So find a common denominator, and I have to use this idea of multiplying by 1. You can see it in blue. Now what happens if All the denominators are the same. You can delete them or just cancel them out. You just drop them. And then look what I get. This goes back to the equations that I had last week. 20x plus 15. I have 15x plus 30. Okay, now remember the number on the left. This goes back to the stuff that we learned last week. I'll subtract 15 to each side. That one goes to 0. Number on the left goes to 0. Then I do it to both sides, just like the steps I taught you. That gives me 15. Now I have to take the variable on the right to 0, so I'll subtract 15x. So I get 0 there. And then I have to do it to the other side. 20 minus 15 gives me a 3x. So let's see what we got. I have 5x equals, it looks like, a positive 15. Now the last step that we learned last week is we have to take the coefficient, divide it by itself to both sides. I do that. I end up with x equals 3. And that is the right answer. Let me go ahead and square that. There's my answers. Okay.